In this video, we will learn about the different types of chemical analysis used by chemists and other scientists. Let's define two key terms used in chemical analysis. A sample is a small quantity of material taken from a larger quantity, which is representative of the original bulk material. When we say a sample is representative of the bulk material, we mean that it has the same or very similar physical and chemical properties to the original source material. A substance in a sample which is being investigated or analyzed is called an analyte. Now that we know these two definitions, let's have a look at some real-life examples of samples and analytes that chemists and other scientists routinely analyze. Chemical analysis is used in medicine. For example, a sample of blood may be analyzed for the following analytes: cholesterol, blood glucose, hormones, or many other analytes. Doctors, chemists, pharmacists, and laboratory healthcare workers perform these chemical analyses to see which medication might be needed by a patient. In farming, farmers and soil scientists might analyze a sample of soil in terms of pH or elemental composition, and this analysis helps farmers determine whether a particular crop is suited to growing in a particular soil and which fertilizer is best. In the food industry, nutritionists and food scientists study the nutrient proportions in different foods, as well as the compounds that give foods taste, for the purpose of suggesting suitable healthy diets to patients and to optimize a food item in terms of nutrient content or taste or shelf life. Let's clear some space. Air, soil, and river samples, for example, are analyzed in environmental studies by environmental chemists for things like toxins and their levels. One last example of where we use chemical analysis is in engineering. Mechanical engineers and metallurgists may take samples of alloys from machinery components to study their elemental composition and related strength. Doing this analysis helps them improve material properties. For example, they can design stronger or more corrosion-resistant machine components. These are just a few of the many examples of chemical analysis in real life. Now let's have a look at types of chemical analysis. We can analyze the chemical substances or analytes in a sample in two ways: qualitatively or quantitatively. Qualitative analysis, coming from the word quality, is the identification of substances in a sample. In other words, identifying what constituents the sample is composed of, which elements or ions or compounds or what mixture of these is the sample composed of. Many samples are mixtures of different components, but some samples are pure. Pure table salt, for example, contains Na+ sodium and Cl- chloride ions. If we were to qualitatively analyze pure water, we'd find only H2O molecules. The qualitative analysis of a blood sample would reveal that blood is a mixture containing red blood cells, white blood cells, water, hormone compounds, ions like Ca2+, the calcium ion, sodium ions, Na+, chloride ions, Cl-, various sugar compounds, gases like carbon dioxide, as well as many other compounds such as urea, cholesterol, etc. These are all analytes that can be identified through the qualitative analysis of a blood sample. Even air is a mixture which we can qualitatively analyze. The components of air that we can identify in an air sample could be nitrogen gas, oxygen gas, water vapor, carbon dioxide gas, argon, as well as NOx gases or nitrogen oxide gases, which are pollutants, and other pollutants such as carbon monoxide, or even solid particulates such as soot or dust. So far we've said that qualitative analysis helps us identify the components in a sample and whether the sample is pure and consists of only one component or a mixture. A pure sample has unique, characteristic physical properties. For example, melting point, boiling point, solubility, and molar mass. Let's think of pure water. We know that it appears colorless with a faint hint of blue, and that it boils at exactly 100 degrees Celsius at 1 atmosphere pressure. In this way, we can identify pure water. Impure or contaminated water samples will boil at temperatures slightly higher than 100 degrees Celsius. Mixtures, on the other hand, first need to be separated into their components, and then these components can be identified. Pure substances can be broadly classified into organic and inorganic substances. We can identify an organic analyte by the elements present as well as the functional groups present in the compound. Many types of electromagnetic radiation are used in modern instruments for qualitative analysis. Organic functional groups in particular are often studied using infrared spectroscopy, which uses infrared light, as each functional group interacts differently with infrared light, giving a signature pattern unique to that functional group. Inorganic substances, such as metal ions, can be identified by the color that they give off in flame tests. Some ions can be identified through their unique reactions. For example, we can identify a chloride ion in a solution by adding some silver nitrate and observing the formation of a white precipitate. Bromide ions, however, react differently and form a cream-colored precipitate with silver nitrate. And iodide ions can be identified by the formation of a pale yellow precipitate, while fluoride ions don't produce a precipitate with silver nitrate. These are just some examples of how to test for the presence of certain substances. Usually, 2 or more tests are necessary to confirm the identity of a substance in a sample. Doing only one qualitative test is not conclusive enough. Now let's have a look at quantitative analysis. The term quantitative comes from the word quantity, which means amount. Scientists often need to know how much of each component is present in a sample. So quantitative analysis is the determination of the quantity or abundance of an analyte in a sample. The quantity of a constituent can be measured in terms of mass, concentration, number of moles, or relative abundance. The various units for these quantities include grams, milligrams, and micrograms for mass, mole per liter or molarity for concentration, as well as parts per million, percent by mass or percent by volume, moles for moles, and percentage for relative abundance. A commonly used and important tool in quantitative analysis is the analytical balance. Analytical balances are sensitive mass balances used in laboratories to measure small masses accurately. Now it's time to practice. Which of the following is not an example of qualitative chemical analysis? A. Determining the concentration of a compound in solution. B. Identifying the cationic groups in a compound. C. Identifying the anionic groups in a compound. D. Identifying the functional group in a molecule. Or E. Determining the elemental composition of a molecule. There are 2 ways to analyze a chemical sample: by qualitative analysis or by quantitative analysis. Qualitative analysis is the identification of substances in a sample. In other words, identifying what constituents a sample is composed of, be it elements, ions, or molecules, or a mixture of these. whereas quantitative analysis is the determination of the quantity or amount or abundance of a substance, be it elements, ions, molecules, in a sample. So qualitative analysis involves finding out the identity of an analyte, while quantitative analysis involves finding out the quantity of the analyte. The question asks which of the following is not an example of qualitative chemical analysis. In other words, they are asking us which answer is an example of quantitative analysis, where we measure the quantity of an analyte. There are various ways to measure the amount of an analyte in a sample. We can measure its mass, or we can determine its concentration, or we can express its amount in terms of moles, or as a percentage in relative abundance. So determining the concentration of a compound in solution is an example of quantitative analysis. Identifying cationic groups is a qualitative analysis. Identifying anionic groups is also a qualitative process. Identifying which functional groups are present is not a measurement of the amount of analyte, and so we can rule this answer option out too. And lastly, determining the elemental composition is all about determining which elements are present and not the amount of each element. Finally, which of the following is not an example of qualitative chemical analysis? The answer is A, determining the concentration of a compound in solution. Now let's summarize what we've learnt about chemical analysis. We learnt that an analyte is a substance in a sample under investigation, and that a sample is a small quantity of a larger bulk material with the same or very similar physical and chemical properties as the original source material. In other words, a sample must be a reliable representation of the original material. We learned that chemical analysis is used in many areas of life and industry, including medicine, agriculture, engineering, the food industry, and even in environmental studies. We also learned that there are two broad types of chemical analysis: qualitative analysis and quantitative analysis. In qualitative analysis, we identify the analyte, or analytes, and these can be elements, ions, or molecules, or even the identification of part of a molecule, such as a functional group. In quantitative analysis, we quantify or determine the amount of an analyte or analytes, and this can be done in terms of mass or concentration, or moles or relative abundance.